everyone, welcome to my channel. Today we are going to be talking about something in Jetpack Compose which is very important, and at the same time it's simple and straightforward. And although it is something that you use regularly if you are using Jetpack Compose, very less is talked about this function I am going to be talking about today, or rather utility I am going to be talking about today. So what we are going to be talking about today is mutableStateOf. What does it do, and how to use it, and how to think about optimization while using it. This is all we are going to be discussing about today. So at a first glance, mutableStateOf is a function that takes any data type object you provide to it and converts it into a mutable state, right? Now, what is state and what is mutable state? State is something that is observed by composable function, and whenever some state is modified, your composable function will recompose, right? Now, what is mutable state? Mutable state is just like any mutable data types in Kotlin or in Android, right? You can talk about mutable list and list. So list is by default immutable, and if you want to add and update, then you use immutable list. Similarly, in state, when it comes to composable state and mutable state, state is by definition should not change. There is no API for changing a state value, and mutable state gives you APIs to change the value of the state, right? Now let's go into the declaration of mutableStateOf. So here you can see that, as I said, it returns an object of mutable state. So whatever you pass here as your value, it converts that into a object of mutable state and returns it, right? Now you can see that there is a second parameter as well, policy, which is a type of snapshot mutation policy. Now what is this? So there might be some scenarios in your when you are writing UI in your app with composable, there might be some scenarios where you might want to have a custom logic on when to update your or when to recompose your composable, right? Or when to consider your state as changed. For example, you might want to trigger recomposition whenever anything happens to your state, right? Any change happens, or when you might want to trigger recomposition, or you might want to prevent recomposition when you are, say, using a custom data class, and you don't, if a part of any property of data class changes, or some property of the data class changes, you don't want to trigger recomposition, right? You don't want to consider it as state changed. So snapshot mutation policy allows us to implement those logic, and there are already 3 predefined implementation of snapshot mutation policy is already provided by Compose. Now before going there, let's talk about what function this interface offers. First one is equivalent and second one is merge. You will mostly need to use equivalent. Now something to notice here is that it doesn't say equals, it says equivalent. So there might be scenarios where you might consider 2 different objects as equivalent if they have some of the properties you consider as same, right? For example, if you're talking about user, right? If user has same ID, same email, and same say name, then you might consider those 2 objects of user class as equivalent, even though their photo might be different, you might consider them equivalent, right? Now let's talk about merge. So merge is something that, as I said, you will not use for most of the cases. This is for edge cases, and that's why they have declared default implementation as well. Now it is useful when your state is being updated by multiple places and you end up with a conflict. So if equivalent returns false, then you can use merge to merge those values and say where you have some applied object and current object where both has some changed values, right? And you want to merge them to create a combined value, then you can use it. And whenever your equivalent returns false, your state is considered changed, right? And in that case, your composable will be recomposed. Now let's talk about the default implementations I talked about. So first one you can see right here in the mutableStateOf only. So it's called structural equality policy. What does it do? It simply does a double equals check of two objects. A is the current one and B is the updated one. And if A and B equals, then it is considered the value has not changed, your state won't be considered as changed, and you will not get a recomposition. Now let's talk about the next one. It is called referential equality policy. So it basically, instead of doing a double equals check, it does a triple equals check. So it not only does check that two values are same, if you have changed the reference, it will trigger a recomposition. Now let's go to our code sample and try to understand. So here I have item here, right? And I am assigning item to my form item something here. This will trigger a recomposition because this item is something different and we are not passing any policy. So by default it is now using structural snapshot equality policy, right? As you can see here, it uses structural equality policy. So something is different, might be different from what this item actually brings in. So it will trigger a recomposition. Now what if I do this? So I am doing this twice. Now will it recompose or will it consider as status changed? Now since it is using structural equality policy, it won't, because if you check double equals with a data class and my form item is a data class, as you can see here. So if you do structural equality or double equals with two objects of data class and all the values in the data class or all the properties in the data class are the same, are holding same values, then it is considered equals or equivalent. So in that case, it won't trigger a recomposition. But if I put policy equals to referential equality policy, in that case, this would be considered as a change of state and thus will trigger recomposition. Now there is another, which is called never equal policy. What does this do? So let's again get back to our sample and let's create and then use this sum item to here, assign here and here. So here I am using the same object and I am passing it to item state 2 times. Now if you are using referential equality policy, second one won't trigger a recomposition. Why? because first one and second one are structurally as well as referentially same. So it won't trigger a recomposition. But what if I want to? What if I have a custom use case where I want to trigger recomposition even if the items are same as reference wise as well as value wise? In that case, you can use never equal policy. If you use never equal policy, then second one as well will trigger a recomposition. Now, we have understood the predefined policies: never equal policy, structural equal policy, and referential equal policy. What if you want a custom logic to it? For example, here in my form item, I have two properties: item details and update count. So update count will basically count how many times this item has been updated, right? And I don't want to recompose my composable whenever update count is updated, because I am not showing it to the user, and I don't care if it goes to from 0 to 1 to 100. I don't care on my UI. So in that case, I would want a policy where it will consider the items as changed or state as changed only when item details has been changed, right? So let's create one such policy. Let's call it my form item policy. It would be a class and it would implement snapshot mutation policy, and it will take my form item as generic parameter. Now let's implement the methods. I'm going to be only implementing equivalent method because I don't actually need the merge method yet. So yeah, now it is going to be very simple. A dot item details, and I want to ignore cases while checking. So if case changed from small a to capital A, I don't want to trigger a recomposition, right? So I'm going to be using equals b dot item details and then ignore case equals to true. And here I will be using my form item policy. You can, instead of class, you can basically declare it as object. So yeah, you don't need to create an object here. So you can, it will be used as a singleton, right? So yeah, now if I do this, right? So say item is equal to item dot copy update count equals to 100. This line won't trigger a recomposition. So that is the benefit of using a custom mutation policy, and that's how you can optimize your composables, and you can reduce recompositions. With this, I would end today's video. Today we talked about what mutableStateOf does, what is a snapshot mutation policy, and how to use it. I hope you liked this video, and please click the thumbs up button, subscribe, and comment. If you have any suggestions on my videos, please do reach out to me or leave a comment in the comment section, and I would love to hear your suggestions, and see you next time.